Now coming to the third type of wired media, that is fiber optic cable, which is the most commonly used nowadays, right? So here the fiber optic cable is made of glass or plastic. Instead of metal, we are using glass or plastic to make the core, and the signals are transmitted in the form of light. Whereas in case of twisted pair, coax cable, etc., signal were in the form of electromagnet or electric current, right? Here that is not the case. Signals are in the form of light to travel through this fiber optic cable. And before moving to fiber optic cable, let us see some property of light. You may have studied these things in your physics classes, right? Yeah, light travels in a straight line as long as it is moving through a single uniform substance, right? But if a ray of light traveling through one substance suddenly enters another substance of different density, then what happens? The ray changes its direction. So as long as the light travels along the same substance, it moves in a straight line. The light moves in a straight line, but when it enters into another substance with a different density, the ray changes its direction. Using this property, actually fiber optic cable works. Like that, if the angle of incidence is less than the critical angle, the ray refracts and moves closer to the surface. We'll see the figure. So angle of incidence we can see here. This is one substance of which is more dense, and this is another substance which is less dense, and this is the interface. Okay, and light moves along this way and it hits on the surface, interface between these two. And if this angle of incidence, in the sense if we draw a line perpendicular to the interface, okay, that line, the angle between that line and the ray, that is the angle of incidence. And it says that if the angle of incidence is less than the critical angle, what is actually critical angle? Here you can see an angle in which after incidence on the interface, the line moves across the surface. You can see the interface surface between this less dense and more dense substance, right? Yeah, if this light moves along the surface, that angle is called actually critical angle. Okay, so if the angle of incidence is less than critical angle, what happens? The ray refracts and moves closer to the surface. You can see that ray refracts. This is the direction after incidence on this interface. Refraction happens. Okay, if the angle of incidence is equal to critical angle, what happens? Obviously the light bends along the interface. Over this interface it moves. This is the angle of incidence which is equal to critical angle. And in the third case, if the angle is greater than critical angle, what happens? The ray reflects, that is, it makes a turn and travels again in the denser. It returns back. Okay, so if the angle of incidence is greater than the critical angle, this happens, a reflection happens. Okay, so these are the properties of light. Based on this, some substance will be manufactured as the fiber optic cable to move the data in the form of light signals. So optical fiber use reflection. The third case, right? The third case, when we move the light, it comes along the same material without going out. Okay, so this property, that means optical fiber use reflection to guide light through a channel. So a glass or plastic core is surrounded by a cladding of less density. Okay, so inner core will be more dense and outer we have a cladding which is less dense. So of course when the light moves in an angle which is greater than the critical angle, then the light moves only through the core without going out to the cladding. The difference in density of two materials must be such that a beam of light moving through the core is reflected off the cladding instead of being refracted into it without going out. That is what you mean by refraction. So such density should be there for the inner core and outer core. So this is how this actually manufactured. We have a inner core. This is either glass or plastic with high density. And outer, beyond that we have an outer, that is cladding, which is again with a substance of less density. And if you pass some light sources, maybe a LED maybe here to emit the light, and if the angle of incidence should be greater than critical angle, then the light moves along the core alone to receive at the receiver. Okay. Now what are the different propagation mode? Which different type of modes are there for passing the signals, and currently we have two different modes, okay, multi-mode and single mode for propagating light along optical channels. And depending on how this core and claddings are constructed, we can achieve this either multi-mode or single mode. Multi-mode can be implemented in two different forms, can be either step index or graded index. So this is the classification. Propagation modes can be either multi-mode or single mode. In multi-mode again we have two implementations, step index and graded index. You can see here these are the different ways of transmitting light. If we are using multi-mode step index, this will be the path of lights. Here you can see that bended form is there. This is multi-mode graded index, and this is single mode. We will see each one in detail how this type of communication is achieved. Coming to multi-mode step index fiber. First one, you can see here multiple rays of lights are there, and they are moving in a different forms, right? Yeah. So how that is achieved actually? In multi-mode step index fiber, the density of the core remains constant from center to the edges, entire inner core, right? The density of the core will be constant throughout the entire core. And a beam of light moves through this constant density in a straight line until it reaches the interface of the core and cladding. We have seen the property of light, right? Like that, for each ray, the corresponding reflection happens. Each one depending on the angle of incidence, the corresponding refraction angle also will be changed. Like that, the ray moves off. And at the interface, there is an abrupt change due to the lower density. This alters the angle of the beam's motion. That why it is called step index refer to suddenness of this change. Suddenly when it enters the interface between the core and cladding, it refracts, right? So that is a step movement. That is why it is called step index. And second one is multi-mode graded index fiber. This decreases distortion of signal through the cables. In the case of step index, the main problem here is that can be distortion, since there is a sudden change when the ray of light incident on the interface. Due to that, some distortion will be there. Signal quality will be degraded gradually. That is called distortion. And to reduce that distortion, we are using the second mode, that is multi-mode graded index fiber, which decreases distortion of the signal through the cable. How it achieves that? Using the construction, the change of construction in the core and all. Okay. So a graded index fiber is one with varying density. The density of the fiber or density of the glass in the inner core, right? That is not the same at the inner level and edge level. That is varying throughout the construction. So density is highest at the center of the core and decreases gradually to its lowest at the edge. So like that, the density will be changed from center to the edge. So definitely the light direction also will be changed according to the densities. It won't be in a straight line. That is why it moves like this. You can see here. Yeah, it is in a bended form, curved form, right? So there is not any sudden change, right? Because of this, distortion will be less in case of multi-mode graded index compared to step index. This is how this propagation modes in multi-mode works. Now coming to single mode. Single mode uses a step index fiber and a highly focused source of light that limits beams to a small range of angles, all close to the horizontal. So in case of single mode, the light travels almost in a straight line, horizontal line, through the core. Okay, don't be any refraction and all. It moves along a horizontal line through the center of the core. The single mode fiber itself is manufactured with a much smaller diameter than that of multi-mode fiber. So the diameter of the core will be less in case of the single mode fiber, so that the light moves along a horizontal line. And density also will be less compared to multi-mode fiber. The decrease in density results in a critical angle that is closer enough to 90 degree to make the propagation of beams almost horizontal. So density is made in such a way that the critical angle of this material is around 90 degree, so that the propagation of beams will be almost horizontal. Now coming to the construction of fiber cable, we will see the cable composition. We have outer jacket, which is actually made of either PVC or Teflon for total protection. Inside this outer jacket we have a plastic buffer, and in between this plastic buffer and outer jacket we have another one. We can see a strand here that is actually made of Kevlar strands to strengthen the cable, to avoid it from breaking and all. We have another set of strands are there, which is Kevlar strands. And what is actually Kevlar? That means it's a strong material which is used in the fabrication of bulletproof vests and all. And below the Kevlar is another plastic. You can see a plastic buffer. It acts as a cushion for the fiber. And then we have the cladding and then the core. Okay, inner we have the core and outer covering we have a cladding. This is how it is actually constructed. Now let us discuss what are the benefits and drawbacks of optical fiber. Coming to advantages, the first one is higher bandwidth. So of course fiber optic cable can support very high bandwidth and hence definitely high data rate than either twisted pair and coax cable. And currently the data rates and bandwidth utilization over fiber optic cable are limited not by the medium but by the signal generation reception technology. So this is able to accommodate whatever bandwidth. Okay, then bandwidth is limited only by the signal generation and reception, never by this fiber optic cable. And second one is less signal attenuation. Okay, so fiber optic transmission distance is significantly greater than that of other guided media. As for example, a signal can run even 50 km without requiring any repeaters and all regeneration. We need repeaters every 5 km for coaxial twisted pair cable. Instead of that, even 50 km we can travel without any regeneration. That much high quality signal will be there. So that is the second advantage. Third benefit is immunity to electromagnetic interference. So compared to metallic cable, which is used in both coax cable and twisted pair, here we are using fiber optic cable, which is less affected by this electromagnetic interference. So noise will be less in case of this fiber optic. So signal will be of good quality. And then next is resistance to corrosive material. So it is not metal or something like that. So more resistant to corrosion, right? Yeah. Then lightweight, of course, compared to that metallic cable, here the weight of this fiber optic cable will be less, and greater immunity to tapping. So in case of those metallic cables and all, tapping will be more, leakage of signal will be more, but here that is not the case. So these are the benefits. Now coming to the disadvantages, definitely that is less compared to advantages. Anyway, some of the drawbacks are there. First one is installation and maintenance. Fiber optic cable is a relatively new technology, right? So installation and maintenance require expertise, of course. And unidirectional light propagation is another drawback. That means propagation of light is always unidirectional, right? So if we need bidirectional communication, two different fibers will be required. And cost also. Cost, the cable and the interface are relatively more expensive than those of other guided media. And if the demand for bandwidth is not high, in that case we could have used the coaxial cable and twisted pair instead of fiber optic cable. For high bandwidth and long distance communication, of course, fiber optic cables are actually preferred. So these are all about fiber optic cables.